The other aspect we were thinking is very important is now something which many countries have added to the curricula, that students should learn adaptive and flexible skills. And that was also some of our earlier findings, that even good students in mathematics were not very flexible in using their mathematical knowledge, and we focused in this question very much because we noticed that there were many students who were particularly boys, who were relatively good in mathematics and were not at all motivated in mathematics. They explained that this is very boring, they do not know where they could use that, and because they had considered the knowledge in a very mechanical way and learned mathematics in a mechanical way, and this didn't support the motivation of future learning of mathematics. And that was the reason why we started to look these flexible and adaptive skills. But that's also something which has been studied quite. For example, USA, Bob Siegler has proposed the flexible strategy use in arithmetics, and Lieven Versaffel and his group in Europe have done a lot of this research. There are Australian studies and many. But we started to look at a little bit more from the point of view of more rich mental representation of networks of numbers, and this is an example of tasks that we have developed to measure that, because the problem in the world, many people talk about flexible adaptive skills, but there's no systematic methods to measure them, and now we started to develop them. This is one example, so that we give numbers, for example this 6, 4, 2, 24, 16, and then operations, and then one target number, and then in 90 seconds students have to give so many sentences as they can by using all these numbers and all these operations, which equals 12. And then this can be scored in so that we just focus on correct solutions. But what we have learned, even more better predictor of this flexibility, if we in addition to that look so-called multi-operational, so that where they use the multiplicative and additive operations in the same sentences. And this is now something which has proved to be, and we have some similar other measures for the flexibility. Okay, but how to enhance in teaching this flexibility? And we were looking at literature and noticed that there were some strategies, some approaches to teach explicitly a couple of strategies for arithmetic tasks, and then how to choose between them strategies in certain connections. But then when we looked for example in the Netherlands, they have applied that model. Then when we looked in big studies in the Netherlands, what have been the consequences of this? It was clear that they have not improved this general flexibility, this teaching of specific strategies, and then, but there were many researchers have criticized that as a too narrow way, that there were no kind of methods then to teach these more general numerical representations which would have been implemented. Many researchers recommend this kind of playful activities with numbers, but then how to implement that in the real situation. And it is clear that this kind of flexible number system needs that there are a strong representation of the number system, and there is opportunity to explore with numerical relation. And then what is needed, a very big amount of training, but not that kind of simple training, but this kind of deliberate practice where they push knowledge forward in a very systematic way. And the only idea we got was that we have to develop a game to support that. And the first game we developed was the natural number navigation game. And there the idea is that there is the archipelagos, and there are materials, and there is a harbor, and then when the player go with the ship to pick up these materials and bring them back to the harbor, then a small village becomes a town, and then a bigger town, and so on, that these materials can be used. And there were in this first version 46 maps and several materials in all these maps. And then we started to experiment with that game. We had a randomized experiment with more than 1,000 students. It was 10 weeks play without any specific teacher support, because we were focused on the effects of the game in the first phase. And the results did show that there was significant for fourth graders. There was a significant improvement for the fluency of mathematics, and for fifth graders there was improvement for the more simple measure of the adaptive number knowledge and the flexibility, but also for the more advanced, this multi-operation. And then for sixth graders, there were a strong improvement of this multi-operation, and also improvement in the pre-algebra skills, which we think is important for that. So that was very promising, but on the same time it was clear that children didn't like this game at all. It was too boring for them. And then there were two solutions. One was that we carried out a second study where we integrated it with an effective teacher scaffolding. So the teacher took a part of a kind of professional development course where they learned to understand the ideas. Of course, there were only two teachers who carried the experiment, so that it was a small scale, but we very systematically helped them to understand these ideas, and then repeated the study with a little bit developed game. And now we got for fourth graders strong improvement for fluency, adaptive number knowledge, and then pre-algebra knowledge. So that it seems that this game, when it is combined with teaching, really can improve this kind of flexible mathematical thinking. But then the second solution was that now we have realized the game in totally different way. Now it looks as a commercial entertainment game, but the game mechanism is the same. And now we start experimenting what now happens when and we already know from some pilot studies that students like it very much, but does it lead to better results? We do not know, and it can be that they pay more attention to the entertainment features and less into the mathematical features. Okay, then still we also have started to study the adaptive rational number knowledge. To look how this developed by using basically similar tasks but with rational numbers, that they have to create these target numbers from these rational numbers in a short time. And then we already have carried one relatively big study. My postdoc researcher is originally from California. He was mathematics teacher there, so that it was easy for him to get students. So that this is from no, not California, from Florida, this US group. And there then we looked with this test where we used the rational number conceptual test, the understanding the magnitude, then arithmetic procedures with rational numbers, then this kind of understanding the representation, so what is the relation between fractions and decimal numbers, and then our adaptive number knowledge task. And we did get with this latent profile analysis 4 profiles. There's the weak students who do not know almost anything about rational numbers. Then there's this interesting group of students. They have no conceptual understanding, but they are almost as good as the top students in these arithmetic procedures with, so that they can repeat mechanically the procedures, but they don't understand practically anything. And then we have the traditional good students who have top achievement in this conceptual knowledge and procedural knowledge, but not in the adaptive knowledge. It's clear that there is this small group of students who have high-level conceptual understanding and procedural skills, and in addition to that are flexible and adaptive thinking. And now this is interesting, that how this can be developed. Because this is something that we know now from some studies from the need of mathematics in future working life. They emphasize exactly this type of flexible and adaptive use of understanding quantitative relations and the use of rational number knowledge in many kinds of situations. So we only have one explanation at the moment. In the same study, we earlier studied the sport tendency, the tendency to pay spontaneously attention to numericity. Then we had the conceptual knowledge measured earlier, and this model tells that adaptive rational number knowledge is, of course, explained strongly by the conceptual knowledge, but also the spontaneous focusing on numericity based on attention. Okay, so these findings of the adaptive number knowledge and the flexibility are now implemented in very large teacher in-service training in the Finnish education model. We got funding from the Ministry of Education to run for several thousand students teachers in-service training, and it is organized so that we go the theoretical background and experiences from all over the world about the ways how to teach flexibility, and then they play our games. We have the natural number navigation game, and also rational number navigation game has already been developed. And simultaneously, when they take part in this in-service training, they have these games and also our task which we have developed, these electronic versions of the task, which they can use in their own classroom teaching. Okay, thank you very much.